Good evening. Today I am going to discuss a problem on electrostatics. Basically, this problem is on electric field and potential. Very simple problem it is. So let us see first the problem. An electric field is represented by E equal to I cap y plus j cap x. Find the corresponding potential function phi. Assume that phi equal to 0 at x equal to 5. So very simple problem it is. An electric field is given in this problem and we have to find potential function phi corresponding to this electric field E. So this is the problem, and there is a condition that phi equal to 0, that is potential equal to 0 when x equal to y. So this is the problem. Now let us see the solution. From the definition of potential difference, we have phi b minus phi a equal to integration a to b d phi. This relation gives us the potential difference between 2 points A and B. Phi b denotes the potential at point B and phi a denotes the potential at point A. And phi b minus phi a gives the potential difference between 2 points A and B. Obviously here phi b, that is potential at point B, is greater than potential at point A, and we can write phi b minus phi a equal to integration a to b d phi. Now from vector calculus we can say that gradient of phi dot dr equal to d phi. At the end of this problem, I will discuss about this relation. How we can derive this relation, I will discuss at the end of this problem. But now we can use this relation in place of d phi here, and in place of d phi we can use grad phi dot dr. So we can write integration a to b gradient of phi dot dr. Now in electrostatics there is a famous relation between electric field and potential, and which is E equal to minus grad phi, where phi is the potential and E is the electric field, and electric field is equal to negative gradient of potential, and this is the relation between electric field and potential of a point. In next video I will discuss about this relation, how electric field relate to potential, and how this relation comes, that how electric field is equal to negative gradient of potential. Now if we use in place of d phi, we can use this relation, and in next step we can write minus of integration a to b E dot dr, since E equal to minus grad phi. Now by question E equal to I cap y plus j cap x, by question E equal to I cap y plus j cap x, so we can use this relation in place of E, and dr is the position vector, and in place of dr we can write dx I cap plus dy j cap plus dz k cap. So we can write this equation, that phi b minus phi a equal to this, and in next step we can write minus of integration a to b y dx plus x dy, because of if we take dot product between these two, then we can easily write it, since I dot I gives us 1 and j dot j is 1. So y dx plus x dy, and there is no k cap term, that is 0, and 0 times dz gives us 0, and that is why there is no third term. So now we can write integration a to b d phi equal to this, that is integration a to b d phi equal to minus of integration a to b y dx plus x dy. We can write this, and in next step we can easily write d phi equal to minus of y dx plus x dy, and in next step we can write d phi equal to minus d of xy, because of if we split up this then we can write this, that is d of xy equal to y dx plus x dy. Now if we integrate both sides, then we can write integration d phi equal to minus of integration dxy plus c, where c is the integrating constant. If we take integration of both sides of this equation, then we can write this equation, from which we can simply get phi equal to minus of xy plus c, where c is the integrating constant. Now by question, when x equal to y, phi equal to 0, and if we use this question, then we can get the value of c constant. So if we use this condition, then we can get c equal to 0, and if we put this value in this equation, then we can easily write phi equal to minus of xy, and this is the potential function, and this is the answer of this problem. So now we are discussing about how d phi dot dr gives us d phi. So let us see. From vector calculus we can derive this. So in place of d phi we can write del phi del x I cap plus del phi del y j cap plus del phi del z k cap dot, in place of dr we can write dx I cap plus dy j cap plus dz k cap, and if we take dot product between these two, then we can easily write del phi del x dx plus del phi del y dy plus del phi del z dz, and which equal to d phi. So such a way we can show that grad phi dot dr equal to d phi, and this was the discussion today. Thank you so much for watching this video.